Thanks for the invitation, and it's my pleasure to be here and show how the Pentacam changed our approach to toric IOL implantation. This has been a change that occurred about 5 years ago when we started analyzing total corneal astigmatism. You know that the Pentacam can give you different corneal powers. Basically, we can use the anterior K1 and K2, which are the traditional simulated keratometry, where the corneal power is the total corneal power is estimated using the 1.3375 keratometric index, which just gives us an estimation of the total corneal power from just the anterior corneal curvature measurements. Alternatively, we can use the total corneal refractive power and astigmatism, which is based on ray tracing through both corneal surfaces. It considers the Snell's law of refraction and provides us with the total corneal astigmatism. You can get these measurements in the power distribution display, where the keratometric astigmatism, K1 and K2 or SYNK, is shown in the first row, and the total corneal refractive power and astigmatism is shown in the third row. So this is what we usually use for toric calculations. And when dealing with posterior and total corneal astigmatism, what do we know about posterior astigmatism? There have been several studies, and they all agree that, as Professor Kohnen showed before, in most cases the posterior steepest meridian is vertically aligned, and such alignment generates an against the rule astigmatism, which partially compensates the anterior with the rule astigmatism and increases the anterior against the rule astigmatism. Here is an example of with the rule astigmatism where K1 and K2 overestimate the total corneal refractive power. Here you see the reading of K1 and K2, which is just 1.4 diopters of astigmatism. Then if you take a look at the total corneal refractive power in the third row, you get 0.6, so big difference, almost 1 diopter between the keratometric astigmatism on the left and the total corneal astigmatism on the right. And the opposite in this case with an irregular but against the rule astigmatism, where you go from 1.9 diopters of astigmatism on the anterior surface to 2.8 astigmatism diopters in the total corneal astigmatism. This makes a difference when selecting the toricity of the IOL. And there have been several studies showing which is the difference between the keratometric astigmatism SYNK and total corneal refractive power. We did one of these studies showing that the difference between the two is about a quarter of diopters, both in with the rule or against the rule eyes. A difference higher than half a diopter can be found in 16% of eyes, while the difference in the axis is lower. But using average values for the difference between keratometric and total corneal astigmatism can be misleading, because the posterior corneal astigmatism is not fixed. It changes according to the amount, to the magnitude of the anterior corneal astigmatism, as you can see from this graph on the right. And of course, if on the anterior surface you have a low astigmatism, you also have a low astigmatism on the posterior surface. So, which is the influence on the outcomes of toric IOL implantations? We published in 2015 with Dr. Neser from Denmark the first study demonstrating that using total corneal astigmatism from Pentacam improves the results over traditional SYNK. And this is a real summary of that study. Where you can see that in eyes with the rule astigmatism, if you use K1 and K2, you get an overcorrection of astigmatism of more than half a diopters, 0.59. And in against the rule eyes, you get an undercorrection of 0.3 diopters. While if you don't use K1 and K2, but use total corneal refractive power, the average difference, the average error, is close to 0 in both cases. So this was the first vectorial demonstration of the improvement of toric IOL calculations using total corneal astigmatism. And this is an example where you see that with the K1 and K2 have a 0.7 diopters astigmatism, and with total corneal astigmatism 1.2, this is against the rule. We implanted the T3 IOL, which corrects in this case about 1.06 diopters at the corneal plane instead of then a T2, and got a planar refraction. And an opposite case where you get 2.7 diopters of astigmatism with the rule, with more than one devices. And if you see with the Pentacam SIM-K is the same 2.8 diopters, but if you take a look at the TCRP, you get 1.8, so 1 diopter less. In this case, we selected a T5 using the IOL calculator available on the Pentacam AXL, where you can select, as you can see here, the IOL model. You can select the IOL formula. You get the predicted power and refraction of the spherical equivalent. Then you can select the toric calculator. The Savini toric calculator uses the value that I showed you before in the power distribution, which is the 3 millimeter diameter reading centered on the pupil using the zone and not just the ring. So this is automatically used to predict the toricity and the refractive astigmatism. And in this case, we got a planar refraction using a T5 rather than a T6, which was indicated by SIM-K. So the last two slides to show the comparison to the Barrett calculator, because there have been some studies suggesting that using an estimated total corneal astigmatism, like the one calculated by Barrett, may lead to better results than direct measurements of total corneal astigmatism by Scheimpflug cameras. And with the latest software update provided by OCULUS, we found that these measurements results using the Toric Barrett calculator and the Pentacam direct measurements are almost the same, as you can see from this slide, where the mean absolute error in toric power was 0.65 with the Pentacam, TCRP, and 0.55 with the Barrett. But if you look at the number, the percentage of eyes with an absolute error lower than 0.75 diopters, the percentage is almost the same, and the centroid error was slightly better with the TCRP by Pentacam. So in conclusion, I believe that we showed that total corneal astigmatism improves the results of cylinder correction with respect to K1 and K2 simulated keratometry. With the Savini's toric calculator, it's easy to make this calculation because everything is automatic on the Pentacam AXL, and the results are very close to those of Barrett, but in this case we have direct measurements and not estimation. Thanks, that's all.